Yo, 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 and happy Friday. This Friday is no different than the other days this week. We're going to continue with the terrain system, and we still have these three different approaches. One default, mostly CPU based, one instanced but still monobehavior based, and one which I call indirect here, which is instance based, and we rely on graphics function calls. And it's starting to look good. So yesterday, I would say that the main thing revolved around getting the shadows to work in the instanced version, and which led us down a path where I learned that, like, having a Shadowcaster pass and doing this with the same clip space position you use to actually render to the screen works in most cases. Still need to dive a little bit deeper into this, but when it comes to terrain like this, extremely big, you might get issues by doing only that. So you actually need to calculate, you need to do some offsetting on the clip space position, and thanks to some functions in Lighting HLSL, Unity handled most of that for us. What's up, Geralt? Good morning and happy Friday. So I would say that was the main thing yesterday. And also, I had a little bit of a trouble actually understanding this. And now when I look at these numbers again, we have this problem. We have triangles that are way bigger than vertices. So maybe it's not fully okay still. But yes, we're gonna start a little bit. We're gonna start easy today. We're gonna clean our shader up, and then we're gonna move, like, the knowledge we got yesterday, we're gonna take that one and we're gonna apply it to the indirect solution and hopefully get that one up to speed as well. If I'm gonna be totally honest, I'm not sure if we will see a big performance difference between the indirect and instanced approach, but we will find out. So vertex shader in the Shadowcaster pass is mostly the same as in the universal forward pass. I would say that, yeah, it's pretty much only this one that's different. And also, we don't actually need view direction world space nor UV here. Fuck, do I want to create... We might want to create our own vertex shader inputs and outputs here. So we might want to move this one down to this pass. And then we copy this one. Because when it comes to the Shadowcaster, we don't need UV. We need position clip space, we don't need position world space. Like we don't need, in the vertex shader output, we don't need anything other than clip space position. So might as well clean it up like this. Ooh, we do need UV as input though. That's very important. And if we take a look at the vertex shader, these two things are the same for both the Shadowcaster and Universal Forward. This one as well. So here we pretty much recreate the position in object space using a height value we read. So maybe object to world, we use this one twice, patch index we use once. Actually, position world space and normal world space. The question is, I'm not even sure we actually need, or like normal in object space. Depends. Like currently making a difference between the normal in object space and the normal in world space is, it's no difference between the two, because we only have a translation here. Can I see a future where we're going to rotate or do something like that with the terrain? I don't think so. And actually, that doesn't really matter. Like we're reading the normal from the height map. Yeah, I'm starting to think that we might just simplify normal world space. We just read it directly from the array or the texture. So in HLSL include here we have approximate normal connected neighbors. We're just gonna say that this is normal world space. Think we don't need normal in object space, so let's clean this one up, make this one. Approximate normal from height texture assume normal should be in world space. So here I also want to add float 3, recreate position object space from texture. And I think object to world, position in object space. Actually, do we really need? Yeah, we just use position in world space after this. So let's do recreate position world space from texture. If we do it like that, I think we can keep these two, this one. We still need the UVs here. So maybe, yeah, let's do it like this. Float to UV. And then we create a function that is float to calculate instance UVs. Okay. Oops. I wonder we might as well just return this one. So calculate instance UVs. Then we have approximate normal connected neighbors. Recreate position. Recreate world space position from texture. Both takes UV, so we do float to UV is equal to calculate instanced UVs. And then we move on to this function, and here we need the object to world matrix. Height value position object space, position object space, position world space. And I wonder, yeah, I think we're gonna take all of this and float 3 position world space is equal to, although do this in a nicer way? I don't know. Height value, yeah, might do just like this. And here we actually have position object space. Yeah, we do need a, so recreate world space position from texture. That's not entirely true. That is not entirely true. So maybe just calculate world space position from texture. Position with height, object space. Yeah, let's do it like this. Float for or position OS, then we offset Y, but and then we take this one and maybe. So UV, calculate instance UVs. Float for position world space is equal to calculate world space position from texture UV and input dot position OS. Yeah. Output position world space is equal to this. Output position clip space is equal to this. Then we do approximate normal connected neighbors. Yeah, from now on we're just gonna assume that this is pretty much world space. Do we need to normalize? No. So just gonna skip all of this and replace this one. A little bit cleaner. Um, 43 input, yeah, okay. So yeah, calculate instance UVs. Or just UV, actually. Patch index, UV. A little bit cleaner. Yeah, let's fix this. 65. Oh yeah, we want to return this one. 202. Oh yeah, that's true, we removed those from here. So when it comes to the vertex shader in the Shadowcaster, we pretty much want to do the exact same thing here. So I'm just gonna duplicate all of this and replace everything except for the last bit. So let's see here, output UV, we don't want UVs to be outputted here. View direction, we don't care. Position CS, very important. Extremely important. UV we don't need, view direction we don't need, normal VS we need, but transform world to age clip. So position world space, the only thing we want to send on to the fragment shader is the positioning clip space. So we don't care about this, and this is not entirely true. Instead of doing unity matrix VP to get multiplied with position world space to get the position clip space, we do transform world to age clip, but we apply shadow bias to the position world space. So we offset it a tiny bit based on light direction and normal world space. So we don't care about this one. We want to calculate both of these, but we don't want to set output here. We just want to do float 3 normal world space. Like this, I think. Let's see what we get. Shadow still working, terrain still working. That looks good. Tiny bit worried about this one, but it shouldn't be too bad. I just want to check one thing though. So like how much better performance do we get if we do garden instanced, if we subdivide it a lot more? Although I wonder, yeah, it's probably gonna look a little bit weird, but we'll see. So now it's 2 to the power of 4, I don't know what that is, 16 or something like that. We do get way less vertices and triangles being drawn at a given time. That's good, I suppose. We also get visuals like this. Okay, we actually do get better performance. I think it has to do with culling. Are we? Yeah, we cull a lot more. Okay, so maybe that's the way to go later on. So you want to find that golden line where, like, the amount you subdivide it for the best performance. Feels nice that it's as simple as just changing these two. But yeah. But okay, so let's see. Let's take whatever we have here and move it on to Terrain Shader Indirect HLSL. We're actually going to we're gonna move this implementation. One sec, let me see. Pretty much the only difference in direct and instanced here is this one, I think. And if I'm gonna be honest, I don't know why. Let's see. So I'm pretty much just gonna take Terrain Shader Instanced, this nice implementation here. Copy all of this, put it in Terrain Shader Indirect. Indirect. Okay, before I continue, let me just commit the changes to this Terrain Shader Instanced. what is the... I always forget. 83. Okay. And I'm also very interested in what kind of performance gain we would see if we reduce this one to approximating the normals from 4 or maybe even 2 texture reads. I think that would be pretty great. But okay, so let's continue with this indirect shader here. So we're gonna solve the instancing in a little bit of a different way. So instead of doing multi-compile instancing, I don't think we need this one. I don't think so. So yeah, the only thing we need to change are these instanced props. So what was it? Uniform float 4x4 object to world 16. The only backside to this, I would say, is that we need to hard code this, and we always have to make sure that this one is the same as subdivision times subdivision. And then also uniform patch index. Uniform float for patch index. Yeah, we had it here as well. And this is what we're going to use here and here instead. So calculate instance UVs, we need to, yeah, also in the vertex shader. No, I don't think we need to do it in the fragment shader, right? No. In the vertex shader here, we need to do, we need to have this one. And it's this instance ID we're gonna use. So I guess in this one it will look something like, first of all, here and here, SV instance ID, and we need to change this so that we can, or at least this one and not this one, I don't think. We do. So position OS UV, and then we're also gonna have a, what is it, uint instance ID, and we want it up here as well. So instead of doing Unity access instance to prop, we do, so it's patch index. We do patch index instance ID. And we do something similar here. Okay, and let's continue and clean this up a bit. Util lighting, we want that one. Unity vertex input instance ID. I don't think we need to specify this now in this solution. So let's skip that one. Let's skip this one. We don't need to do this, but we need to send in SV instance ID here and here, right? we don't do this. Okay, and for the Shadowcaster we need to do the same type of things. So let's remove this one and this one. We already have SV instance ID here, so okay, is that it? And then I'm actually going to do... Am I ready for this? Okay, so we have... Yeah, let's delete this one. Terrain default indirect material, terrain default instance material. And we have this difference here. So even though like this indirect thing here, it's basically we are drawing a one object multiple times, so instanced, but in the shader, on the shader side, we do it in a little bit of a different way. Yeah, I'm very interested in the result here. Okay, so terrain shader indirect. We have the indirect solution here. Let's hide instanced. Enable this one and assign the correct material. Do we have the same? So everything is pretty much the same here, except for the material and this one. It's very cool. It's cool to see the difference, I think. So terrain base instanced and terrain patch instanced. What we do here is let's take a look at patch first. So patch here is actually a mono behavior with its own transform and stuff. One thing though, let's see here. I'm a little bit worried about... let's just compare here first. So terrain patch instance is its own mono behavior with its own mesh renderer and mesh filter component. And then we set some property blocks to have some instanced properties in the material. So when we create the terrain base, we actually create it using multiple terrain patch instances. So multiple mesh filter and mesh renderers sharing the same mesh and the same material, but with different material property blocks. Terrain base indirect is a little bit different. So here terrain patch indirect is just a struct storing index and object to world matrix, and we then use it in the base indirect here when we set some data, which I think we can improve this quite a lot. So when it comes to max height, patch length, delta UV, delta VS, terrain data texture. Or actually, yeah, when it comes to, I'm not sure we want to do, so here we create a new property block and we set these matrices. I'm not entirely sure we actually need to do this, but we will find out. This is all new, so I don't know exactly how it's done. Very important. So what I'm a little bit worried about as well when it comes to terrain-based indirect is, first of all, this one. So world render parameters world bounds. So this is pretty much the bounds for the entire terrain base. Very over the top for now. But this much pretty much implies that I'm just worried about, like, do all the patches share the same bounds? Because if so, the culling might be harder to do based on bounds. I don't know if it's based on another approach here. A lot of question marks, a lot of possible improvements, but we will see, we'll see. So we're gonna try indirect now. Same dimension, same vertex count, same texture resolution, same subdivision. Everything pretty much the same. Yeah, so instantly we can see this. We have half the FPS, a little bit more. And I'm pretty sure, almost entirely sure, that this is because of we don't cull properly. Very interested in this, how we can make this work. But we can see here when we do graphics, we have mentioned it multiple times now, but when we do graphics.render indirect, we don't actually see how many vertices and triangles we render. So these verts and triangles are only for the character mesh and apparel. Okay, but everything renders correctly. It's just that we get half the FPS. So let's take a look. I'm not too sure here. Yeah, I'm not too sure we want to rely on this one. I'm very interested in this one though. If we do, let's see here. I'm starting to think that our solution terrain base instanced is the way to go. I think. Although I want to would like to compare the performance of this one with terrain base, but without actually calculating the normals on the CPU. Actually, it's irrelevant, I think. Okay, let's take a step forward. So let's disable this one. Let's rely on garden instanced. And I want to see if we can implement some, let's see here. Actually, this one is not done, but this one is done. So I'm wondering if we're going to try and implement ground collision using height texture. And then maybe even start with the terraforming. Depending on how long it takes for this one. So the basic idea is that our entities that move are going to pull the terrain. Probably gonna rely on a singleton solution for now. Maybe. So I wonder if we want to go, let's see here. Are we using this one? Index IJ. Okay, so I think we're gonna do this. We're gonna do public. It's always scary how when you want to, how should I put this, work with the Unity physics system in a unconventional way. But we'll see. So environment, what do we have? Ground and different terrain solutions. So I want to add a environment controller. Environment controller. Let's add this one. Something like this, and then I wonder if we also want, okay, for now we're gonna go require component type of terrain base instanced. Yeah, and we're actually, we're gonna put this under namespace. Terrain, and we're gonna do, since we have required component, we're just gonna do terrain is equal to this, and oh yeah, come on. And we're gonna do terrain.generate. And then we're gonna add a method here, which, okay, so this one, I'm very curious to see how this goes, but it's pretty much going to be something like public float get terrain height for position. So in terrain instance we need to have a method that is, so given a world position, we're gonna read from the texture. And I wonder if we want to do something like okay, so first of all, what we need to figure out here is how do we handle a world position outside of dimension. And I'm thinking of doing something like so if world position is less than transform.position.x, is it, let's see, 0.5 minus 0.5f times dimension.x, right? Pretty sure. Or while position.x is bigger than transform position.x. And then the same in the z direction, right? Actually, let's do bool is within bounds. Actually, now when I think about it, bounds unity, can we utilize bounds here? Contains, fuck yeah. So I think we can just do, although yeah, it should be okay. Private bounds. Bounds is equal to new bounds. Height range. Just Y here, and then of course we need to offset this one with, oh, what is it? I always forget. Is it minus? Let's double check. Terrain patch instanced. Yeah, we basically just want to do this. Like this. What's up, Top 5? I'm doing fine. It's Friday, you know. How about you? Okay, so now we have our bounds here. Top 5 doing fine, working at home. Oh, nice. Gotta love it. wishing I was working on my project. Oh yeah, that I can relate to. So here we can just do, I think we're gonna do if bounds dot contains world position, like if it doesn't, then we return, I don't know what one would return here, but I think we're gonna go with 0. Otherwise we're gonna need to read the texture. And let's see here, texture 2D Unity. Let's see what functions we have, because I would like to avoid, like I would like to read a pixel using float UVs here. Don't think that's possible. We'll see. What's up, Harukanan, and happy Friday. So if we have get pixels, yeah, okay, beautiful. Get pixel by linear, I think this is what we want. So UV normalized between 0 and 1. Love it. So all we need to do is convert the X and Z coordinate of this world position into normalized U and V based on dimension. So I guess that's as easy as doing, we just want to return terrain data dot get pixel by linear world position dot x divided by dimension dot x. World position dot z divided by dimension y dot r. Okay, not really, but almost. We have to remember that although it's very unlikely, this terrain base might be offsetted. So we need to take or we need to take, let's see here. Yeah, we need to take the bounds into account. Do we have bounds? What do we have? Contains. Okay. So I guess we want to do if we do minus transform dot position dot x, so this one goes from okay, I want to test this, but and we're gonna have our terrain at 0, but so first we offset it to if we're like, let's say for instance that the terrain is 1,000 units away from the world origin, then we make, and we're running around on that terrain, we want to move us back to the world origin, so we do minus transform position dot x, and I also think we need to do minus 0.5 f times bounds dot, actually but we can also do extents, and then we don't need to do half, right? So if we're running around, it's pretty much like we take, you could see it as we take this world position and we transform it down to terrain object space, right? But with terrain object space origin being at the bottom left corner. Maybe not. I think this is how we want to do it, but I wouldn't be surprised if there's some problems with the math here. That's for show. And we're gonna have a lot of functions just like this one, because this terrain data is gonna contain so much more data than just height. But for now, let's do this. And then if we go to environment controller, we get terrain height. Here we just do return terrain dot get height world position. Okay, let's open up entities, player movement. Do we use ground? Oh, we don't actually have a ground check here. I thought we had. I'm pretty sure we should have somewhere around here. In-air responsiveness is grounded, entity dot is grounded. Okay, so entity handles it. Beautiful. Immobile animate entity. Oh, this is great. This is beautifully set up. So, animate entity, ground check mask. So right now we do a physics check sphere to see if we are grounded. And we just do it when we pull. Okay. We're gonna do it a little bit differently here. We're gonna add an additional component. And this shouldn't really be player movement, it should be entity movement, I think. We're gonna generalize it a lot. So this one shouldn't handle input handler. Instead, I want to do, yeah. But so we're gonna do entity ground check. Yeah, and the ground check is not only going to be available to the animate entity, it's actually going to be available to the entity. Because we want to be able to check it on everything. I want to see player movement. Yeah, let's see. Okay. Physics, I don't know. I don't know, ground collision checker or something like that. Ground collider check. Ground collision check. Ground collision checker, I think. Yeah, I'm very interested in how this exactly will work with when it comes to character. We have something like rigid body. Angular drag and drag. Drag was 0 though. That was... I'm pretty shocked by that, but that's good. Use gravity. Let's see. Ground collision checker. So it's basically going to be private void. What is it? Fixed update, right? Fixed update. Yes, and here we want to do ground collision checker. We're going to require some components here as well. Rigid body might be the only one. What is the... What do I usually go with here? Movement... RB. Do I actually... Okay. I'm usually very explicit, but just in this specific case, we just go with RB. Probably because of the name collision here. Which I think this one has annoyed me ever since I started with Unity, I think. But yeah. Private void. Okay, so I want to do 3 tests with this pretty much. So we're gonna do, first of all, we're gonna start with, we're gonna do a fixed update. We're gonna get, in fixed update, we're gonna pull the terrain about the height for ground collision checkers world position. If we are like intuitively, I would like to solve this by, like, we check how close we are to the ground. If we're within an error range, then we add minus gravity force upwards. That's pretty much how it works in real life, right? Question mark. But I'm assuming that we're gonna get like some form of jumpy behavior if we do this, but maybe not. And then I also wonder if this works, what happens if our character falls extremely quick. But whatever, let's try it. So very interested in how this will look and work. Do we care about the check here? Probably. So if this is bigger than transform.position.y, basically. And also you might want to get the, like right now I'm just going to add a force straight upwards, but you might want to add it like the opposite of the terrain normal. I don't know. And I don't want to, probably don't want to change. We're going to do some tries back and forth here. I think I don't want to change velocity directly. So instead add force. Physics dot gravity times ooh, okay, interesting. So just this, I guess. Yeah, we're gonna remove all of this. It feels like it slows us down a bit. Character 01, we're gonna add a playable entity. Yeah, let's fix the entity side of things first. So animate entity is grounded like this right now. Instead we're gonna use I'm gonna go to entity and we're gonna add require component type of ground collision checker. Or actually, fuck it, require component, no, we're gonna do add component ground collision checker. And then what do we have? We have bounce, weight, Yeah, we can skip most of this actually. Let's take this one and move it over to entity. And here we're just gonna do return ground collision checker. Yeah, fixed update, let's add a public bool. Yeah, we're gonna do it like public bool is grounded, returns, then we need to check. Robert Pattinson, what is your opinion on things? What things? Gotta be more specific. And is this gameplay programming finally? Yeah, we're dipping our toes. We're dipping our toes. My opinion on stuff and things, they are stuff and things. I'm trying to have a neutral opinion about stuff, you know, about stuff and things. I would like to be able to avoid like a check like this. I'm not entirely sure if we... Can we do this? Or is it more is grounded get return false, because then we don't have a ground. Otherwise return this. It's so fucking long. Do I want to do this? And then we can do just skip this and do is grounded. While you were making your game, I took part in 2 game jams already. Parentheses, the games are not good. Well, congratulations. I guess one of them was Ludum Dare or Ludum Dare. I don't know how to pronounce it. I fucking really wanted to join that one, but I had some other plans that weekend. But well, like I was about to ask how did it go, but like you finished 2 game jams, so that's nice. Good job. Feel free to share the games if you want. Okay, ground collision checker. Let's see how this works. I'm a little bit worried. I'm extremely worried actually. I think this is gonna destroy pretty much everything. To rely on this instead of physics. Nah, I'm good. Okay, well, good job anyway. Yeah, let's try this. So what do we have? Is grounded. So in entity we can do is grounded. We just do send it onward. So ground collision is grounded. Very nice. And then in player movement, yeah, we check entity is grounded. The entity reference here is animate entity, but yeah. The falling here though, so yes, we are already underground. One more thing. I think we need to... I'm not entirely sure. Let's see here. Ground collision checker. We have it here, but don't we run it? Okay, so this could actually be multiple problems. Let's see. What we do here is, if is grounded, we add force in the opposite direction of physics gravity, and is... The question is if this one is negative or positive. I need to check it. But then we do environment controller. It's also... Do we have this one? Do we have this one? Yeah, we do. God damn, how many components are there? There's a few. It's not that many. Okay, so environment controller, I think, so we have this one. I guess I'm gonna have to check, but we do transform position. Environment controller, get terrain get height, world position. Okay, so the first test I want to check is ground collision is grounded. Let's do debug.log is grounded check. Debug.log ground check, or hey. Do I need to do this? Okay. And also physics Unity. Although I think we can check that one in our settings as well, but let's see. Gravity. The gravity applied to all rigid body in the scene. Okay, let's see. Project settings, physics, gravity 0 minus 9.81. So I guess that's what we're getting. Grounded check true. What's up, Dev Spires? Thank you so much. Okay, so is grounded check, we do it. Grounded check is equal to true. That's a good sign. So this one is true. We do RB add force minus physics.gravity. I guess we would also like to do times time dot, what is it, fixed delta time. But still, what this tells me is, like, even though we didn't have this one, we should still apply like enough gravity to push the character upwards. For some reason we don't. And I don't know why. So, if this doesn't work, let's just add an obscene amount of force upwards. So I don't know. Okay, so maybe wait with this one. But let's do 1,000. Hopefully that will make the character fly or fall in the opposite direction. Okay. Okay. So the question is, like, if we add 9.82 in the opposite direction, why each frame? Is it that we need to add to the velocity? Because this works. I want to, oh no, actually, let's see here. Let's add this amount, but we also do force mode. Add a continuous acceleration to the rigid body, ignoring its mass. Like, which one is default, by the way? This one is default, is it? Impulse. Ignoring its mass. I'll try this one. Probably not going to be the correct one, but we'll see. Or the fuck? How good does this work? I'm a little bit... Okay, this one... Okay, slowly but surely we're moving downwards. Okay. Not a big fan of the frame rate as well. So I guess like the ugliest way to do this would probably be is grounded, then we do rb.velocity is equal to, can we do .y here is equal to, no we can't, so it's equal to new vector 3 rb.velocity x, and here we do math f.max of 0 and rb.velocity y, and but like I want to avoid adjusting the or setting the velocity in directly like this, but maybe that's the only option we have. And then of course is grounded. Yeah, now we're gonna do this in a bad way, but set position or whatever it's called, rb dot move position, moves the kinematic. Don't we have set position or something like that? Okay, but the ugly way to do it would probably be to do rb dot transform dot position is equal to, in a similar fashion here. So this is the under the assumption that we are grounded, although here we would do environment controller dot controller get terrain height, so something like this, like setting the velocity in the y direction to 0 if it's negative, so nullifying the gravity force or any downwards force actually, and then setting the position to the terrain height in the y so we don't get any falling through the ground, but like setting the velocity directly not recommended, and setting the transform position of a rigid body directly not recommended. So Yeah, but hopefully it works. We'll see. But, like, yeah, here we would probably want to be a little bit higher up. Yeah, we don't have that much. Yeah, why don't we get... We should probably be... I mean, it feels pretty good. It's extremely slow to slow down. But other than that, it feels good. And we can jump. I'm a little bit worried why we didn't see a... Okay, what's going on there as well? Oh, is it actually so high up we can't see it? Okay, I'm a little bit worried why we didn't get moved up around here, but whatever. And let's see. Let's bring our character up here. Okay, that's interesting. So it's actually like we have a height of 0 everywhere. Okay. Grounded check false. True. Whoa. Let's take a look at this one. Symbols, question mark. Why do you always have the same thumbnail for live streams, even though your character now have green clothes? Good question. I like this thumbnail, and yeah, maybe we will create some new ones. So get terrain height. If this height is bigger than transform position Y, then we're grounded. So why the fuck? So right now we're getting ground check true, ground check false. Are we getting false on some of them? Okay, let's do this. We're gonna do environment controller, terrain base instanced, max height. We're gonna go with. Actually, we're gonna remove this one and this one, and we're gonna go with max height. I don't know, 10. Let's see what we get. Yeah, we should, first of all, we should see our character at a higher position. What is this? Yeah, okay, so it's pretty much like, okay, so the problem is hopefully with terrain-based instance, this check here, if bounds doesn't contain world position, will return 0. I think this is what is happening each frame, so we might want to start there. But before we do that, I just need a new cup of coffee and I need to brew it. So be right back. 5 minutes. Okay, back. Sorry about that. Let's see. So, I'm pretty sure. I hope this is what happens. We return 0 here all the time. I should have ground check. We should have just checked, or let's see here. Ground check. Debug.log. Ground height. And we do this. Okay. Actually, I know what the fuck is going on. So we get pretty good values here, but the wrong ones. So we just do like terrain data get pixel bilinear. Hopefully we get them from the correct U and V's, but we don't multiply the height with the height range. So min and max 10 here. So we should do, I think we're gonna do, so here we get the value. We also want to do height range.lerp. So we get a pixel from the red channel of the terrain data texture. The red channel is the height. So we get a value between 0 and 1 here. And then we lerp that, so whatever value we get, we send into height range. And now we should get the correct height. So now we should also see the character jumping up into the air, or fly up on the terrain. And we should be able to run around on the terrain, or so I hope. Okay, still not entirely correct here. If we can't get more, if we can't get better values than this, then I'm a little bit worried. Or then I'm actually very, very worried. Could be that we don't have the correct UVs, so I hope. It should be. Let's try it. Let's run to the end. Actually, we can't. Let's do. This, I think. Yeah, pretty sure we're not getting the correct values here. Ground height 0. Okay. I have honestly like zero idea what's happening here. Okay, first of all, ground height. Yes, okay, I might have some idea. Oof. Ground height 0. Yeah. Okay, first of all, we moved ground checks to entity because we wanted exit it, reopen it. Yeah, I think this error is a little bit bigger than that. But let's see. So we added ground checks to all entities. The only problem with that is that the apparel is also entities. Yeah. So basically, enable physics here. Enable colliders. What we want to do here is ground collision check. We want to do public bool enable. Enabled is equal to true. Come on. Active is equal to true. Fixed update if not active, return. Or actually, what the hell? I think we can just do it like, we don't need this. We should have this in mono behavior, like we saw it in the naming collision, so we should be able to do enable colliders. Here we do ground collision checker dot enabled is equal to enable. I'm still worried though why we're not seeing the proper offset of our character. Is the position on the terrain that wrongly calculated? Okay, so now we only have one character. Or one ground. We actually have two ground height checkers. I'm very interested in which this one is. Oh yeah, we do it in... Ground collision checker is enabled here for this one. Yeah, that's not good. Jesus. Okay, so entity, let's do ground. It's a bit weird that we ground collision checker we create it here. Let's take a look at apparel handler then, because here we do we do it in yeah, we do it in start, and then when we do add apparel, we do apparel where, and here we do entity enable physics false, but oh yeah, but we still allow for collisions. Yeah, that's true. So we're gonna do entity enable colliders to enable physics. Oh yeah, we set them to. That is true. So maybe we should just have this one here, I think, instead. Okay. Let's check it now. So we want to disable. So the idea is that if an apparel, for instance, that is an entity, if it's equipped by the character, we want to disable most of the physics, including this newly implemented ground collision check. Okay. So now I think we only have the character ground check left, and we get a ground height of 0 at all times. Why is that? So ground height is 0. Ooh, do we check terrain base instance contains yeah, let's add one more check or one more debug. Texture terrain texture read terrain texture get height read. Okay, so we actually don't get any of those. Okay, that means that bounds.contains world position returns false at all times. Now to the question, why does it? Center transform position plus half of height range delta times vector up. That probably has to do with it. So I want to check. We want to do terrain patch instanced. So right in this one we have on draw gizmos, draw wire cube, and we draw the mesh renderer bounds. We know that works, so we're gonna move that one to terrain base instanced and put it here. Bounds center, bounds size. I'm pretty sure that it's the center offset here that is wrong. I'm pretty sure. But yeah, I think we want to do let's take a look. I think we want to probably not offset it the center at all. But let's see. Okay, it's quite big, might be hard to see. Ah, fuck, it looks good, to be honest. It pretty much looks like it should. Looks beautiful. So what's up? I think it looks... Yeah, I think the height of it is good at least. Yeah, and we can see here that the position of it is good as well. So why the hell would this one... If bounce doesn't contain world position here, return 0. We'll never get to this one. Terrain texture get height read. So ground height. This be it? I don't think so. Dimension X, Y, no, I don't think so. What the fuck? Bounce under bounce size. Works beautifully. I think height range was... Get terrain height. Environment controller, get terrain height, terrain get height. Terrain base instanced. Like what? What up? If bounds doesn't contain world position, return 0. Like I'm 100% this is what happens. Actually, ground height 0. But we try to move up to 1. Okay, not anymore. Walking like Mario indeed. What the hell is going on here? Height range slurp. Return 1. Like we return 1 here. And we can see here that when walking like Mario, this one we set the position in Y to 1 over and over and over again. Although we get a print here of 1, that's weird. Oh, terrain texture get height read. Now we get a height read here. Why is that? And when we do get the height read, we get 0. What's up, Cooler SK? This is weird. Something is very wrong. One sec. Did I? Ooh, whoa, 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 whoa. Yeah, this is probably not correct, right? Let's see here. World position. I guess we could do it like bounce. We could probably do min max the minimal point of the box, center minus extents. Yeah, I wonder if we, just to make sure, we might want to solve this like so instead we do it like math f dot inverse lerp between bounce dot min, bounce dot max, world position dot x. Oh yeah, dot x, dot x. And then we do the same here. But then again, the fact then we don't need divided by this one, I don't think. Right? Said. I'm pretty sure we can do it like this. But I've been pretty sure about a lot of stuff today that turned out to be wrong. So I wouldn't bet on it, but let's see. This one still seems to be wrong for some reason, and I can't wrap my head around it. Like, sometimes we get 1 here. Actually, let's do it. I want to try ground collision checker. Let's do BAM and BAM. So and here I want to log this, I think. So, or actually, no. I want to vector 2 temp. With UV plus temp. So let's print the UV coordinates and see if it's correct. Oh, Robert Pattinson, I don't know if you're still here, but are you implementing your own physics system? I didn't even notice that question, but let's just put it this way. I'm trying to implement proper, like we have our own terrain system, and I want a very, like, most of the terrain related stuff is going to be like the meshes, the offset is going to happen on the GPU, but we still want our characters to collide with it. So we can't rely, since the information, like the height information doesn't exist on the CPU more than in a texture, we can't rely on Unity's physics system. We need to handle the collision with the terrain ourselves, and that doesn't really work. Rage Run Games, wow, the Toonie shade looks great. Thank you, appreciate it, appreciate it. Terrain texture get height, read with UV 0.5, 0.5. That is great. But what happens Then we start run around a bit, and then we stop getting this print, which means that we are outside of the terrain bounds, and we are fucked. So for some reason, I don't know why, this one starts returning true. Like this one returns false, but true thanks to this one. And I don't know why. Draw wire cubes. Cube shows the correct. Like this wire cube is fantastic. And this one actually returns the correct thing, at least for the few initial pulse. Zero 0.5, 0.5. We get 0.49. That's great. 0.51. Let's see if that is the correct values. Calculator. So we're at 37 divided by, what is it? 2000. 0.0185. 0.0185, 48, 52, or plus actually. Yeah, that seems like it seems to be correct. Why doesn't this one return the correct thing? What am I missing? Oh well, like it seems like this one doesn't return it either, so terrain data. Could it be? I would be very surprised if maybe, like, do we need to rotate it or something like that? Oof. Like, it's pretty clear that something is wrong with this. Terrain data, we fill it. Set pixel. How do we fill it? I times texture resolution subdivided dot x, and that's I. We fill it. Is it x to y? Jesus. I wonder if I can fill this in some way that we get the same terrain offset. I'm a little I'm afraid that the way we create the terrain and the way we try to pull the height doesn't match. We have a mismatch in transform in some way. NG, by the way, thank you so much for a follow, appreciate it. So let's go back to only using the test terrain data texture 64 times 64 2, because I think this one is, so this one is repeatable, but like it could also be that we're inversed. Yeah, we can see this doesn't work either. It's extremely frustrating. Okay, actually, what we can do is this. Let's try this. This might be pretty cool, I think. So, on draw gizmos, what we're going to do here is we do for is less than, actually we do float I is equal to 0.0, I is less than 1.0f, actually less than or equal to, and we do 0.01. Is that too small? 0.1f maybe, and then we do a similar for loop for in the other direction, and then we do actually, will this okay, let's start by doing, yeah, let's start by doing this, and we do float y is equal to float 3 world position is equal to, and we do I times dimension. Then we get the height by doing this, and then we do gizmos.draw sphere. I don't know, radius 1.0 maybe. Let's see what kind of result we get here. So we should get a lot of spheres being aligned with the terrain, and here we use world position to draw based on bounds. I'm still not entirely sure about this. We're gonna get an extremely high frame. Okay. Is this too many gizmos? Is it seriously that slow? How many are these? 1,000. I don't even know if I want to try with less. Let's do it. But how many? Let's try with 10. But this is pretty much no data at all. I think the result here... maybe let's try it. Okay, so with 10 gizmos, I don't even know. Do we even see them? Like... Okay. What's up, Redstone? I'm pretty good. Having second thoughts about this terrain stuff, but yeah. How about you? Whoa, 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 whoa. Why don't we get any spheres whatsoever here? Do we need to do that? Yes, we do. Okay. Okay, I get it. I think. Yeah, we need to offset it by... Or is it minus? Pretty good. Made a new 3-4 cover image for the Twitch category. I'm currently making levels. Like the Twitch category for your game? The fuck? That is very cool. Bounce and no, we want to do bounce dot extents. Or actually minus extents, I think. But yeah, as soon as we get the spheres in the correct place, at least, like the X and Y position should be correct. Okay. Semi-happy with this one. But it's extremely hard to check this. First of all, we want, when we draw these, we want, shouldn't we have like gizmos dot depth. Yo, what's up, Meister K? Oh, fuck, why doesn't this work? Let's see here. Gizmos and depth check. We're currently working on a... Let's see, I'm trying to remember when you were last in here. We're still working on the terrain system, but now we have moved on to... So we can properly render the terrain with normals and height. And now we're working on getting a simple terrain collision in place. Pretty much. But it's not going very good so far. Like basically we have a big texture that represents our terrain, the height of our terrain, and we want to do for every entity in the world, we want to check against that texture. Like we want to check the Y world position for the entity, and we want to compare it with the height and then properly set it. Create tri-mesh collision. Yeah, like this is like way simpler than actually just checking, like doing any form of collision checks. Basically what it comes down to is we do something like what we do here is we do environment controller get terrain height. If this terrain height value we get is bigger than our transform position Y, that means that our entity or our object that has this component is underneath the terrain. So if this is true, like we just do a float value comparison, and if this is true, transform the object up to the terrain level. Like there's not even, like it's a collision check in one dimension basically. But so the problem is probably most likely the conversion between world space position of the entity, so the world position, and the actual position in the texture. So we want to convert a world space position to a UV position in the texture, and that conversion seems to be a little bit wrong. So we're just in the middle of debugging that. Okay, we can probably make it a little bit easier to debug by making our height have our terrain have a height of 100. Like this, and then if we go to scene view, we have a set of spheres here, and I think it actually looks like the spheres are, let's change the so right now what I'm doing is I'm just pretty much plotting 10 spheres on the terrain and see if the height value of them varies according to the terrain. Although it's extremely hard to see. But looks to be all right. What's up, Fabic? Yeah, it looks... it's extremely hard to see. The terrain is big, but yeah, it looks to be alright. So, now we know that if we create a world position like this, and we read from the height texture like this, then we get a correct world position. It seems. Jesus, Gizmo is not very performant. Yeah, it looks to be correct, definitely. Ooh, this one, however, is a little bit questionable, isn't it? Yeah, that one sucks. Like, if we want to do collision with this terrain, this one right here, DDG, thank you for the follow. Love the name. But then again, this is a very... we won't see anything like this in-game. Like, this is also very too steep, but still. Maybe it's okay. Okay, I'm starting to think that... are we... we're a little bit... something is off. For sure. Yeah, maybe I'm a bit too optimistic when it comes to the texture resolution. What can we do? Let's see, environment controller. I don't know how this one looks, but let's see what kind of result we get if we do 128. Yeah, fuck it. Let's do a texture of 128 times 128 pixels, and we do 256 and let's see here. If I do 512, so we have a terrain that is 512 times 512, both in Unity dimensions and vertex resolution. Then we subdivide it twice. Now let's go subdivision like this and 512. I think this should be it. So we are gonna get 128 times 4. Yeah, okay, so we're gonna get terrain that is 512 in vertex resolution and dimension. It's gonna be represented by a texture that is 512 times 512 pixels. And it's going to be represented by 4 times 4 patches, where each patch is a 128 times 128 texture. Let's see. Okay. Oh yeah, okay, texture is not readable. Let's change that first of all. Read write. Okay. I guess this is as good as it's going to get on this resolution, but if we change to environment controller, so yeah, if we would your texture has MIP maps generated. Can it be a problem? Let's check that, Fabric. Let's check it. I mean, this is... it's rough. It's extremely rough. Okay. I don't think we have any MIP maps. So the texture itself has MIP maps, MIPs generated. So this one. We can try and disable it, but like the text, the actual terrain texture is this one, which we create here, and this one has MIP chain as false. So it shouldn't be this one. But who knows? So right now we basically, we take the character world position, we read the corresponding value in the texture, and then we offset the character to be to that height. And extremely rough. I guess we could do it with... We might actually want to do... Okay, first of all, let's just say I was anticipating a bad result by doing this. So we do get pixel by linear. But not this bad. Maybe. Let's see here. Terrain 2D. Filter mode, but then again, I need to think about this. Let's do environment controller. Let's add this one as well. Do I want to spend too much time on this, or like, do I want to spend time on this, or do I just want to opt for creating mesh colliders? If you put filtering to not be point, maybe it will smooth out the movement. I'm pretty sure, like what this tells me, that we can stand here, is that we're not using point as filtering mode, but I don't know. That was my first instinct as well, that we might... But... yeah. Like if we were using point mode, I don't think this would be possible. Let's try it. But yeah, terrain data dot filtering mode. Let's set it to filtering mode point. Let's see, how does this affect mesh generation or the shader? Let's try it. Fabric, but set it not to point. Yeah, that's what I'm saying. Like, I think it wasn't set to point. Now I want to check if it was set to point or not. Actually. Interesting. Okay. So let's set it to bilinear. I'm very interested in ground collision. Like, I know we shouldn't be doing this, but right now we just set the position and the velocity. So now we're running with bilinear, so let's see. Yeah, I'm thinking that bilinear is the default setting, right? So bilinear is what we had from the start. Yeah, I don't really get this, the result we're seeing here. It doesn't make much sense to me. But then again, okay, so now it's point filtering, right? Works pretty good. Okay, so this is point. Okay. Like the very, it looks better on smaller, yeah. So yeah, so the very steep hills we're seeing, those are, we're not gonna have anything like that in game, so we don't really need to support good collision detection there. Now we have bilinear filtering and it's like fucked up, right? If we have point filtering, we get a better result on small hills. Weird, but true. Yeah, okay, so basically we want to... Yeah, okay, so, okay. I'm starting to understand this. So, basically when we do this height check, we want to... Right now we do it in a very bad way. We just read one pixel value from the texture. Basically what we want to do when we compare the height to the terrain is we want to... Best case scenario would probably be to like try and reproduce a small bit of the actual mesh that is going on, and I think it would be enough by like reproducing a triangle. So I guess we're gonna have to read 3 values from the height texture. We reproduce a triangle exactly like it would be for how it's actually rendered, and then we do some collision checks against that one. Then we get a normal as well, I think, and yeah, that would probably give as good a collision as creating a mesh collider. Like, this is actually not too bad, I would say. It's a little bit janky and stuff like that. Foot IQ will fix, yeah, Foot IQ will fix some parts at least. I need to fix character 01 prefab, player movement, in-air responsiveness. Let's go with 1, because it's like when we do checks like this right now, it's often, I notice that when running downhill, it's often like the character is in air instead of on ground. Still, the performance is shit though. Extremely depressive. Like, to be honest, let's do let's do garden 512 512 512 512 2. Okay, we can only have 1, so let's go with this one. Let's enable this one and disable this one and regenerate. Okay, maybe chill with the height difference. What did we have on this one? 10. And then we have our character here. Okay, let's do... Fuck, did I remove that? Okay, let's see. Entity... is grounded, ground collision checker. And also one more thing, ground collision checker. Okay, this makes me a little bit happier at least. So this is... This is CPU generated terrain. So we generate normals. It's way better performance actually. It's a little bit janky as well with the collision, but... So this is generate the mesh, generate the meshes and the normals on the CPU, no instancing, and we also use a mesh collider, and we're getting, I don't know, 50 more FPS. Very weird. Now what? Okay, so the collision, even though we use a mesh collider here now, we base it on the mesh. We base it on the mesh collider. No, so the mesh collider is the mesh of the terrain, and we still get pretty janky controls here. So that's not that big of a difference between the other solution. It's almost like I prefer the height map collision comparison one. What bothers me the most is the actual performance. The performance is better because you don't have to read the texture data every frame to calculate the position. So instead, if one would do let's hide this one, let's enable this one again, and we do ground collision checker. We don't do anything here. Environment controller. Yeah, I don't know if this is the culprit though. Do we have any collision now? Like what we've been doing now, is it that slow to read from a texture on the CPU side? Fuck, so what do we actually want to do? Like, so right now, pretty much this terrain system compared to the naive solution, this one pushes a lot of the work over to the GPU, so we don't generate any normals on the CPU. We pretty much just generate one grid mesh, and then we render that one multiple times to change the height and stuff like that. I need to think about this, like how I want to solve the collision if we use this approach. Purely rendered based. Do we have 200 FPS, or what is it? I don't know. And what's up, Brack, by the way? I see the terrain is getting into shape. Yeah, slowly but surely. Yeah, I need to figure out the way forward here. So we still have two different approaches to it. Like, it all comes down to I don't know. Okay, so okay, that's true. So I would like to implement terraforming as well on the terrain in question. And if we get that in place and some proper collision, like, we can choose to do a custom height map collision solution, or we could I don't know, if we're going the doing the mesh collider approach, then we might as well have the mesh collider, then we might as well solve most of the things on the CPU. I don't know. Fabric, you have one very big texture that has to be read for every movement calculation. It will be even slower when you will try to edit the terrain. I used the texture approach and it didn't work for me. Yeah, you're probably correct. I'm gonna have to look into this, how to solve it. But unfortunately, it won't be today. And Robert Pattinson, I don't have any commands. Well, I have a lot to think about this week and how to approach this problem. I don't know if I will have a plan by Monday, but yeah, I'm gonna have to run now. But thank you so much, as always, for watching, and have a great weekend, everybody. Peace.